Assalamualaikum and salam sejahtera to Dr. Afifah and all my friends. Today, we will be presenting about digital system design for our group task assignment for BNC 2413. We have 3 students in our group. Firstly, my name is Muhammad bin Azraq bin Muhammad Adnan and my number matric is B0220100134.
Next one is me. It's Muhammad Zafi bin Muhammad Effendi. My matric number is B0220101155.
And for our last group member is Muhammad bin Hazi bin Amizan with matric number B021 910051. For question part 1, I, Muhammad bin Azraq, will be presenting about how to design, simulate and verify a fully parallel 6-bit by 6-bit unsigned multiplier digital circuit with 1-bit full adders and half adders as building blocks. Inside, this is our schematic diagram for 6-bit by 6-bit multiplier. And on my right side, this is our coding for bits multiplier. For our module name is part 1 coding, and the input is X and Y. For the output is P. Then the wire is declared as W1 to W84, which is W is wire. Then for N1 and gates, the output is P0. The input is X0 and Y0. For N and Q, the output is W1 and the input is X1, Y0. For N and P, the output is W2 and the input is X0 and Y1. For the half adder, which is we declared as HA, is N4 and the output is A1 and the wire 3 and the input is W1 and W2. For half adder, it has 2 output and 2 inputs. Then for N5 and gates, the output is W4, the input is X2 and Y0. Skip the AND gates and I will explain about full adder is FA and 7. The output is W6 and W7. For the input, we have 3 inputs for full adders, which is W4, W5 and W3. So this is our coding for 6 bits multiplier. We name as part 1 coding. Then for half adder coding, our module name is HA. This stands for half adder. The input is S1 and the output is sum and cout. Then for XOR N1, the output is sum and the input is XY. For 926 and N22, the output is cout and the input is X and Y. For full adder, our module name is FA. The input is X, Y and CIN. The output is sum and cout, while the wire is declared as N1, N2, N3 and N4. This is line 27 as of, and the output is N1. The input is X and Y. For line 29 and for the output is N2 and the input is X and Y. Lastly, the line in the line 32, the output is cout and the input is N2 N3, and N4. For the test bench, we name as our module is TB part 1. The input is X and Y, while the output is for wire P. For the initial begin, our input for X is 6 bits, binary 101101, and for our input Y 110111. So we will simulate the test bench. Then for the input for X is 101101, while the Y is 110111. So at the output, we can see the output is 1001011011011.
For part 2, Mohammad Zafi will design and simulate and verify a synchronous digital system that detect and recognize your student ID as password that can be used to generate and output signal. Okay, we have Mealy Fsm machine here. We declare S0 is 1, S1 is 0, S2 is 1, and S3 we declare 0. For FSM coding, we have declared input clock, input reset, input X, and output for register Z. For parameter, we declare S0 equal to 1, S1 equal to 0, S2 equal to 1, and S3 equal to 0. For the next state, we have declared if reset state equal to S1 and else state is go to next state. For S0, if X begin to Z equal to 0, next state will be go to S1. For next, if Z1 equal to next state, Z equal to 1, next state will be go to 0. S1, if X begin to next state, if 1, it will be go to S2. Okay, if Z equal to 0, the next step we go to S1. S2, if next state go to S1, if 1 is go to S1, and for next state 0, it will go to S2. Next, S3, if Z equal to 0, it will go to S3, and Z equal to 1, it will go to S0. This is our FSM coding and test bench. We have declared for input, register clock, register reset, and register X. For wire output, we declare wire Z. For initialized input, we have declared 15 for clock, 15 nanosecond per cycle, and input of X we have declared 10010. We run this simulation. What we have can see here, we minimize first. The output for digital signal will be have see here. First 15 nanosecond, what we have can see here. The X will be reset until 45 nanosecond, and the Z will be 0, and the reset it will be go from 15 second. The next is for 45 nanosecond. The X is 1 and the Z will be 1 because of we input to 1. So the next 15 nanosecond, the output the input for of X is 0 and the output will go 1 because what we have declared here is 0 for line 58. And next again repeat again with this one. We have declared for 59, line 59 we have also declared 0, and x 0, the z will go 1. For the next cycle, what we have declared here is 1 for line 60, and it will have a 1 for x and z equal to 0. And for next line is 61, input of x equal to 0, this one is 0, and the output